The directions say to solve each differential equation by variation of parameters. Let's take a look at example 1. Suppose I'm given y double prime plus y equals secant x. So let's note that f of x is equal to secant x. First, we're going to set y double prime plus y equal to 0 to find the complementary solution y sub c. So just like before, we're going to let y equal e to the rx, y prime is r e to the rx, and y double prime is r squared e to the rx. So my characteristic equation is r squared plus 1 equals 0. Solving for r, I get plus or minus I. So my complementary solution y sub c is equal to c1 sine x plus c2 cosine x. So what I'm going to do is let y1 equal sine of x and y2 equal cosine of x. And I want to calculate the Wronskian of essentially y1 and y2. Now I'm going to write this up here, that the Wronskian of y1 and y2 is the determinant of a 2 by 2 matrix where the first column is y1 and its derivative, and the second column is y2 and its derivative. And so that's exactly what I did. So the Wronskian of sine of x cosine x is the determinant of a 2 by 2 matrix where the first column is sine x cosine x. The second column is cosine x negative sine x. So this determinant is equal to negative sine squared x minus cosine squared x, which is equal to negative 1. Now, w sub 1, just as a side note, w1 is the determinant of a 2 by 2 matrix where the first column is 0 f of x, and the second column is y2 and its derivative. And that's exactly what I did. So notice that W1 is the determinant of a 2 by 2 matrix where the first column is 0 secant x. The second column is cosine x negative sine x. So this determinant is 0 minus cosine x times secant x, which is equal to negative 1. Now, let's take a look at W2. So I'm going to erase W1, and let's write down W2. W2 is the determinant of. So in the first column, I'm going to get y1 and its derivative. In the second column, I get 0 f of x. And so W2 is the determinant of a 2 by 2 matrix where the first column is sine x cosine x, the second column is 0 secant x, which is equal to sine x times secant x minus 0, which is equal to tangent x. So what we want to do from here is integrate u1 prime, which is w1 over w, which is equal to negative 1 over negative 1, which is equal to 1. And so u1 is equal to x. And we're going to forego the constant. So it turns out we don't need to write x plus c. Integrating u2 prime, which is w2 over w, we get tangent x over negative 1, which is equal to negative sine x over cosine x. So u2 is natural log of the absolute value of cosine x. And we're done. So my y is equal to c1 sine of x plus c2 cosine x plus x sine x plus cosine x natural log of the absolute value of cosine x. And so, in other words, these first two terms happen to be the complementary solution. The second two terms happen to be the particular solution. And one thing I want you to note on the particular solution, y sub p is u1 y1 plus u sub 2 y sub 2. That's how we get the particular solution. And this right here is example 1. Let's take a look at example 2. Suppose we have y double prime plus 3y prime plus 2y equals 1 over 1 plus e to the x. My f of x is equal to 1 over 1 plus e to the x. Just like in example 1, we're going to set y double prime plus 3y prime plus 2y equal to 0 to find the complementary solution, y sub c. So y equals e to the rx, y prime is re to the rx, and y double prime is r squared e to the rx. My characteristic equation is r squared plus 3r plus 2 equals 0. Now, if it helps, we're factoring the left side. And so when you factor the left side, you get r plus 1 times r plus 2, and we're going to set that equal to 0. Solving for r, we get r equals negative 1 or r equals negative 2. So my complementary solution, y sub c, is equal to ae to the negative x plus be to the negative 2x. So y1 is equal to e to the negative x, and y2 is equal to e to the negative 2x. So the Wronskian of e to the negative x, e to the negative 2x is equal to the determinant of a 2 by 2 matrix, where the first column is e to the negative x, negative e to the negative x. The second column is e to the negative 2x, negative 2e to the negative 2x. Calculating the determinant, we get negative 2e to the negative 3x plus e to the negative 3x, which is equal to negative e to the negative 3x. So remember, that's the Wronskian. My w sub 1, remember it's the determinant of a 2 by 2 matrix, where in the first column, we're going to have 0 in the function. So in other words, we're going to have 0, 1 over 1 plus e to the x. In the second column, we have y2 and its derivative. So in other words, we have e to the negative 2x, negative 2e to the negative 2x. And so w sub 1 is negative e to the negative 2x over 1 plus e to the x. W sub 2 is equal to the determinant of a 2 by 2 matrix, where in the first column, we have e to the negative x and its derivative. So in other words, we have e to the negative x, negative e to the negative x. In the second column, we have 0 in the function itself. So in other words, we have 0, 1 over 1 plus e to the x. So calculating W2, we have e to the negative x over 1 plus e to the x. U1 prime is W1 over W, which is equal to, it turns out, e to the x over 1 plus e to the x. U2 prime is W2 over W, and when we calculate that out, we get negative e to the 2x over 1 plus e to the x. So U1 is equal to natural log of 1 plus e to the x. And again, we don't have to add the plus c, it turns out. U2 is negative the integral of e to the 2x over 1 plus e to the x dx. And I did a u substitution here. I let u be 1 plus e to the x. Du is equal to e to the x dx. And I go through and I get negative the integral of u minus 1 over u, which is negative of u minus the natural log of u, which is negative of 1 plus e to the x minus natural log of 1 plus e to the x. And so the tough part is the simplification. So remember, y is the complementary solution, which is ae to the negative x plus be to the negative 2x, plus the particular solution, which is plus e to the negative x times natural log of 1 plus e to the x, minus e to the negative 2x times the quantity, 1 plus e to the x minus natural log of 1 plus e to the x. And so in my first step, I distributed the e to the negative 2x inside to each term within the parentheses. And when I did that, I got y equals ae to the negative x plus be to the negative 2x plus e to the negative x natural log of 1 plus e to the x minus e to the negative 2x minus e to the negative x plus e to the negative 2x natural log of 1 plus e to the x. And when it's all said and done, my final answer is y equals a sub 1 e to the negative x plus b sub 1 e to the negative 2x plus e to the negative x plus e to the negative 2x, that quantity, times natural log of 1 plus e to the x. And so ultimately, I believe your instructor would want you to get down to here. Now, if you got to here, this step, I'm thrilled, right? As an instructor, I would be thrilled. But really, the ideal is to be able to get to this step, to simplify completely. And that's what you would get. Okay, that'll conclude this video. This is differential equations, and we did 2 examples utilizing variation of parameters. Thank you.